final module on global climate change. So this is really the conclusion of this course, and what I consider to be actually one of the most important modules of the entire course. And so a lot of what we're going to be talking about is really crucial information. So there's going to be a few more videos in this module than there have been in previous modules, but hopefully it won't take too much longer to watch them than in previous modules. So this module is going to cover four main things: the concept of climate change, the context of climate change, the causes of climate change, and the consequences of climate change. And then at the very end, I'm going to conclude things by talking about some things that are being done to fight climate change and some things that you can potentially do to fight climate change. Now, before we even get started with this module, though, why do we even talk about climate change? It's such a major buzzword, and a lot of people really are very heated arguments about it. There's a lot of stuff about climate change that is really been sensationalized and popularized. So why do we even talk about it? Well, one of the reasons why we talk about it is because there's a lot of misinformation out there about climate change. Case in point, this cartoon that I'm showing right here. I found this cartoon on a political webpage, and I won't say which party, but I assume you could probably tell. You could probably guess which party. And what it shows is it shows a baffled scientist crossing out different words: global cooling, global warming, climate change, climate disruption, and all of these things. And then this rather inaccurate definition of it. Meanwhile, over here, there's a smart aleck little boy who writes, it's called weather. Now, the problem with this is that, as we've talked about in this class, weather and climate are two very different things. Weather deals with the day-to-day, here and now, moment-to-moment condition of the atmosphere, whereas climate talks more about the average, long-term condition of the atmosphere. Now, both change. Weather changes from moment to moment, whereas climate changes over an extremely long period of time. Now, one of the problems with this is, first off, this definition here is very misleading. Dramatic temperature changes in the temperature and the state of the atmosphere. It's extremely misleading because that would be a good definition of weather to an extent, but it's definitely not a good definition of climate, and definitely not a good definition of climate change. The other thing wrong with this is that it was overly politicized. You see all these things here: Al Gore, Inconvenient Truth, and so on. And one of the biggest problems in modern day climate science and in climate education is the fact that it's such a politicized issue now. And personally, I wish anybody other than Al Gore was making these Inconvenient Truth movies, because he's a Democrat, and I hate to admit it, being a Democrat, half of America immediately tunes him out. And it's a frustrating thing. But with that said, we're going to try to dispel a little bit about what climate change is. So that's our first lecture today, or for this module. We're going to talk about the concept and the context of climate change. And hopefully by the time we're done with this cartoon will seem more foolish, more rubberish, more rubbish than anything. So let's jump in. First off, what is climate change? It's not dramatic changes in the temperature and the state of the atmosphere. And the reason why it's not that is because, while yes, there are dramatic changes happening, and while yes, the state of the atmosphere is changing, that could happen either in the short term, weather, or in the long term, which is climate. When we talk about climate change, we're talking about long-term changes. We're talking about how the average condition of the Earth is changing. Not just how our day-to-day weather's changing, but how the long-term of it is changing. So what is a good definition of climate change? Well, the best definition that I could come up with is that climate change is the term that we use to describe the reaction of our atmosphere to the anthropogenic, that's just a fancy word for man-made, gases that have been emitted into it. So basically, when we talk about climate change, we are specifically talking about how our Earth, and specifically our atmosphere, how it has reacted, how it has changed, how it has responded to what we've done to it. Now, climate change is the current really popular term. Climate disruption, I don't know what that was all about. Climate change is the big term. Now, before climate change sort of became the big definition or the big term that we used, a previous term that was used was what was called global warming. Now, the problem, however, with the term global warming is that it's an overgeneralization of what's actually happening. When we talk about climate change, we're not just talking about warming. Rather, we're actually talking about how the atmosphere and how the condition of the atmosphere is changing all across the board. So we're not just talking about temperature changes, we're talking about how wind directions are changing, we're talking about how humidities are changing, we're talking about how cloud cover's changing. We're actually talking about all the different facets of what you and I know as weather, how each one of those things is changing from location to location. Not only that, but global warming also is misleading because it assumes or it presumes, it gives you that assumption that global warming or that the Earth is warming uniformly, meaning everywhere across the Earth is warming and it's warming the same amount. However, that's not true. There are actually some regions across the Earth that are experiencing cooling, believe it or not. A good example of this is regions near the coast. And there's a phenomenon called coastal cooling where warmer inland temperatures are leading to a higher temperature gradient, that's a change in temperature with distance, which leads to a high difference in pressure, which leads to stronger sea breezes. And there's actually been research that's been done suggesting that areas near the coast are actually cooling rather than warming. So that's one reason why global warming is a misleading term, and one of the reasons why we as climate scientists have actually thrown it out. Because it's so easy for a politician who has no understanding of what they're talking about to walk in and say, well, look at the temperature of Half Moon Bay down by the ocean. It's cooled. Therefore, global warming's not happening. And so we've kind of thrown that term out. So when we talk about climate change, the reason why we call it climate change is because there's so much more happening than just increasing temperatures. Now, with that said, yes, the Earth is warming. And I'll talk more about how we know that later in this lecture and in the next lecture. Now, how do we actually know that the climate's changing? How can we, as climate scientists, even gain an understanding of if the Earth is changing, if the climate's changing, and how it's changing? Well, in order to do that, we need to look at the past climate. Well, that brings us to an important fact. The Earth's climate is always changing. That's actually an argument that's commonly used by people who have problems with the issue of climate change. They say, well, Earth's climate's always changing. Absolutely. Earth's climate is always changing. But how do we know that the changes that we've experienced over the past century, over the past 150 years, how do we know if those are just normal up and down variations, or if there's something more alarming. Well, in order to do that, we have to compare these changes to changes in the past. Now, how are we actually able to view previous climate? Well, it's very tricky. We have to perform what's called paleoclimatology. Basically, what we do is we look at the Earth's past. We look at the Earth's past by looking at evidence, such as fossil records, such as sediment samples, and so on. Now, why should we care about this? Well, we should care about this because the more we understand the previous climate, the better we can understand what's currently happening. And how do we go about doing this? Well, as I said, we perform what's called paleoclimatology. In a real sense, what it is it's almost like forensics, in a way. We look at evidence, we look at signs from the past. Things such as I mentioned, fossil records. We look at sediments, we look at ice cores, tree rings. All kinds of things can tell us a lot about the gas composition of the previous atmosphere, whether it was a good growing year or a bad growing year, whether it was hot or cold. And that, combined with what's called carbon dating, can tell us a lot about when a particular sediment, or what year, what time did that particular sediment represent. So these are some of the ways that we can look into the past. And then there's actually a lot more to this, and there's a lot more discussed in the book about this. However, there's just not enough time to cover it right now. With all that said, though, combining sediment samples, combining tree rings, combining ice cores, looking at fossil records and previous species and what happened, what we can actually do is reconstruct our previous climate to a pretty good degree. So here's what we've come up with. The first thing that we've come up with is over the last roughly 700 to 800 million years, we've actually been able to identify 3 major glacial periods. These are times where the Earth is covered with more ice than it's not. The first major glacial period was 700 million years ago. Another one was 300 million years ago. And then the most recent one was 2.5 million years ago. And that one was what's called the Pleistocene epoch, also known as the Ice Age. So when you watch the movie Ice Age, they're actually talking about the Pleistocene epoch. Now, we are still technically in the most recent one, and the reason why we say we're still technically in the most recent one is by looking at what's called the geologic timescale. Ice ages don't just start and end 1 year to the next. Rather, it takes millions of years for an ice age to go through its full evolution. And so we're still technically in the most recent one. Now, the Pleistocene epoch began with a cooling trend about 55 million years ago. And then over the past 2.5 million years, we've had variations in ice coverage. There have been periods of advancing and retreating glaciers. The advancing periods are called glacial periods, and the retreating glacial periods are what are called interglacial periods. Those periods are much warmer. Well, the most recent glacial period was approximately 22,000 years ago. And in that time, polar regions were over 20 degrees colder than they are today. Tropical regions were over 5 to 10 degrees colder than they are today. Now, what this actually does is when you have more ice, that water's got to come from somewhere. Well, that water came from the ocean. And so when we had more ice, there was lower sea levels. As a result, sea levels are substantially lower, and parts of land that are currently submerged may have been exposed. And it's actually believed that in order for humans to make it from the cradle of civilization, which is near Africa and the Middle East, to where they are today, which is now everywhere, 20,000 years ago, we didn't have planes. The only way you could cross an ocean was by migrating. And it's believed that a land bridge was exposed called the Bering Land Bridge, which allowed people to cross over from one area from Asia over to North America. And then this glacial advance ended about 14,000 years ago, and then a new one began about 12,700 years ago, so a little under 13,000 years ago, called the Younger Dryas. And then that ended a little over 10,000 years ago. So this is how the world looked 18,000 years ago. 18,000 years ago, many of the places we know and love, Chicago, much of the Northeast, Boston, if you're a Red Sox fan, St. Louis, much of the Mississippi River Valley, the Sierra Nevada, the Cascades, all of Canada, were covered in ice. And if you take a look, much of Europe, including all of Great Britain, a good part of northern Italy, southern France, parts of Spain, and all of Russia was covered by glaciers. The Younger Dryas happened, as I said, about 12,000 years ago, 12,700 years ago, after a nice little peak in temperatures, and then temperatures then rose back up about 10,000 years ago, and we've had this relatively minor variation in temperature over the last 10,000 years. However, if you actually look at the very end of this period, there's another sharp increase. That sharp increase is what global warming is. That sharp increase is what everything that we're going to be talking about for the rest of this module is. In order to really see what's happened in a better context, let's actually zoom in and look at the past 1,000 years. Now, the closer we get to modern day, the more accurate our temperature records become. Why? Because we have better instrumentation, bigger population, better understanding of how to accurately take a temperature, and so on. Well, in the past 1,000 years, here in the northern hemisphere, we have experienced practically or pretty much cooler temperatures than what we're currently experiencing. A big exception to this was the 11th to the 14th century, so roughly 1000 to 1300. In this area, or in this time period, Vikings were even able to populate Greenland. After the 14th century, though, we entered a period called the Little Ice Age. And the Little Ice Age began around 1400 and it ended a little after 1800. And in this time, there was significant cooling across Europe and North America. This was not worldwide cooling, however, and there's still a lot of speculation about why this happened. This graph shows us a little bit about how temperatures have varied over the past 1,000 years, though. As you can see, compared to 1961 to 1990 averages, so basically looking at the last 4 decades of the 20th century, most of the past 1,000 years were actually substantially cooler. However, if you take a look, around 1800, this is also when temperature observations became much more accurate, we actually saw a big increase in temperatures. And we've been seeing that big increase really over the past 150 years. Now, zooming in further, looking over the past 100 years, we have very accurate results. At this point, with a higher population, with better technology, with better standardization of observation techniques, and so on, we've really been able to get a key look at what's been happening temperature-wise. And what we've noticed is that there were two real major temperature rises. There was a big one in the early 1900s and an even larger one in the late 1900s. And in between, there was a leveling off and even a slight cooling trend between 1945 and 1970. And a lot of that cooling off had to do with increased volcanic activity, which we'll talk about in the next lecture, as well as decreasing industrialization post-World War II. That was just one thing, though, and there are a few other potential causes. And in fact, even looking at data, there's even been some suggestions that the leveling off might not have been as beautiful as we would have thought. Here's how the past 100 years have looked like. This is again compared to roughly the previous 50-year average, more like the 1951 to 1980 average. And what you see here is the beginning of the 20th century was pretty cold. The end of the 20th century was pretty hot. And then, as I mentioned, we had a little bit of leveling off right in the middle of this time period. So, with all that said, what has actually happened? Well, if we take a look at global average temperatures, the last 4 decades have been substantially warmer than any time in any of the history that I've mentioned. So everything I've talked about so far, the Pleistocene epoch, the Holocene, everything I've talked about, we are actually in the warmest temperatures we have ever been in any of what I've talked about recently, earlier in this lecture. And what we've actually noticed is that every single year is getting increasingly warmer. Now, how much warmer has everything become? Well, according to the 2014 Intergovernmental Panel on Climate Change, we'll talk more about this group in a few lectures. Well, according to this group, between 1880 and 2012, so roughly the last 135 years, average global temperatures have increased 0.85, give or take 0.2 degrees Celsius. This is a statistically calculated trend. A statistically calculated trend. This over here, this 0.2, is what's called the uncertainty. And this takes into account potential errors, anything that could go wrong in the observations. And with these two things, we can say with 95% statistical confidence that the Earth has warmed somewhere between 0.65 degrees Celsius and 1.05 degrees Celsius in the last approximately 135 years. So there's been substantial warming over the last approximately 130-ish years. Now, in the next lecture, we're going to talk a lot about the causes. First, we'll unpack the natural causes, then we'll talk more about what we've done to change the climate. Until